All right, y'all, are you ready for exam 2? The course is just flying by. So let's get started on reviewing for exam 2, which covers, we're written down here, chapters 3.2 through 3.7. So let's do this. All right, first one, find the derivative of the function. So when we find the derivative, this is just the power rule for this one, except we want to make sure that we rewrite any fractions or roots. So in this case, and again, if you still don't know how to rewrite roots, I have a whole exponents little tutorial, so check my YouTube videos for that. So x to the 1/2 minus 8x to the 1/3. Now we're going to take the derivative, which means we're going to pull these powers down and we subtract 1. So 1/2 x to the negative 1/2, bring this 1/3 down, multiply it by the 8, so negative 8/3 x to the, subtracting 1 is like subtracting 3/3, so that'd be negative 2/3. So this is your answer, or you could write it like this, 1/2 square root of x minus 8/3, the cube root of x squared. This one, so if I want to rewrite this, that would be 7x to the 1/3 plus 6 cosine x. And then you take the derivative, you bring the 1/3 down, so it would be 7/3 x to the subtract 1, so negative 2/3. The derivative of cosine is sine. Oops. Negative sine. C, change sign. And take the derivative of something with a C, you change the sign. So negative sine. So that's that answer. Determine the point where the graph of the function has a horizontal tangent. So we're going to take the derivative. When you see the word tangent line, you should think derivative. Horizontal means that it's flat like this. So it equals 0. And I remember that by this is a horizontal line and it can make a z for 0. So take the derivative 3x squared plus 9, and then we're going to set it equal to 0. Now here's the thing. This actually doesn't have any places where this will equal 0, because you're not going to be able to square a number and then add something to it and ever get negative number. So I can just picture this graph as a parabola shifted up 9. It looks like this. So it never crosses the 0, like the y equals 0 line. You could try to solve it by subtracting the 9, but then you're going to get x squared equals negative 3. And that's an imaginary number. And we're not talking about I. So we're not going to have to worry about that one. So the answer would be none for that one. This one, if we take the derivative, we do get something that equals 0. We get 2x, and that equals 0 when x equals 0. Find a derivative. So the derivative of that is the square root of 3x plus 2 cosine x. Okay, so the square root of 3 and the x, this is a coefficient. So the derivative of that is just root 3. 2 cosine changes to negative 2 sine. So that's the derivative. Then it says where it has a horizontal tangent. So we set this equal to 0. So we get root 3 equals 2 sine. Divide by 2. And so we're asking where's the sine value, which is the y value, positive root 3/2. So I went up a lot, the bigger version. So that would be at these places right here, which this is pi over 3, and this is 2 pi over 3. So the smaller value, pi over 3, and then this one is 2 pi over 3. Find the y values by substituting them into the function. So we want to actually get the points. So pi over 3, comma, plug pi over 3 into this guy. So root 3 pi over 3 plus 2 cosine pi over 3. The cosine here is 1/2. That's the x value. So square root of 3 pi over 3 plus 2 times 1/2. So that'd be plus 1. So root 3 pi over 3 plus 1. Similar over here, 2 pi over 3, you would plug that one in. So you're just going to get a negative 1/2 for that. So this would be a -1. So similar idea. Find k such that the line is tangent to the graph of the function. Okay, so basically this means take the derivatives and set them equal to each other. So k x to the 1/2, the derivative of that would be 1/2 k x to the -1/2. And the derivative of this is just 5. So we have this equation. We need two equations though. So if it's tangent, that means it's touching at this one point. So we're actually going to set them equal to each other as well. So if I solve for k here, I would get k equals 5x plus 20 over the root of x. And I have this here. So I have 1/2. If I plug in what k is, 5x plus 20 over root x. And then that's 1 over this x to the -1/2 is 1 over the square root of x also. So I can put that in the bottom equals 5. So but what I did right here is I'm solving by substitution. I just thought it was easier for this particular problem. And I set the functions equal to each other, and I set the derivatives equal to each other. And then I'm substituting for, because if you have two unknowns, you need two equations. So these are f's equal, and here is f primes equal. So let me change my color so you can be better. So this, I got 1 times 5x plus 20 times 1, so that's just 5x plus 20. On the bottom, I have 2 times the square root of x times the square root of x, and that would just be x equals 5. So I can cross multiply that over there. 5x plus 20 equals 10x. Subtract the 5x, so I get 20 equals 5x, so x equals 4. And if I want to find k, I can plug it into this right here. So plug in 4 here and 4 here. So it would be 20 plus 20 over the square root of 4, which is 2. So we have 40 divided by 2, which is 20. And our question is find k. Find k. So k is 20. Hold on, I'm videoing. Hold on. Okay, between there's the average rate of change the greatest. So where's the slope the greatest? Hold on. The slope would be the greatest between A to B, steepest slope. Is the average rate of change of the function between A and B greater than or less than the instantaneous rate of change at B? So instantaneous rate means the tangent line slope. So instantaneous rate is this rate. Average rate is the rate, the secant line, which would be through the 2. Sorry, my line is not perfectly straight. So which one is more steep? The blue one. So we would have that the average rate is greater than that instantaneous rate. Sketch a tangent to the line between C and D, but hold on, can you wait just a minute? Okay. Sketch a tangent line to the graph between C and D such that the slope of the tangent line is the same as the average rate. So this one is tricky. I don't really love the way this is. So if I was to graph the line between C and D, again, I wish, do I have a line function? Yes, I do. Okay. Well, let me see, can I scoot this over? Nope, undo, okay. Okay, there's my line, there's my tangent line. So I want the slope to be parallel to this. So it looks like it's this one here. I have a hard time drawing a perfectly straight line. So if I was going to draw a line between C and D, there's some place between C and D where, like this one, where you've drawn it at the tangent spot where it's parallel. So you're just looking for something that's parallel to that line between C and D. So that would be this answer choice here. Use the product rule. I'm trying to see how many we have left. Oh, well, quite a bit. Okay. Use the product rule. The product rule is the derivative of the first times the second plus the derivative of the second, which is negative sign, times the first. So 7e to the x cosine x minus 7e to the x sine x. Quotient rule, derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. When you square this, you get 10. Because power to power, you multiply, and you can simplify from there. Find f prime of x and f prime of c. So here I see that there's a product. So derivative of the first times the second plus the derivative of the second times the first. And then we're going to evaluate that at c. So we're going to substitute in 0. So that would be 0 plus 2. These would be 0, that negative 2, 0, 4. And those would both be 0. So that zeroes out. And over here we get 2 times negative 2, which would be negative 4. For this one, we need the product rule because we have 2 functions of x. So the derivative of the first times the second plus the derivative of the second, which is negative sign. So it's like a minus times the first. I'm going to plug with pi over 4. So cosine of pi over 4. I need you to wait. So cosine of pi over 4 is root 2 over 2 minus pi over 4 times root 2 over 2. So root 2 over 2 minus root 2 pi over 8. Find the derivative of the transcendental function. Hold on just a second. Okay, sorry about that. One of my boys is having a hard time. Okay, so find the derivative here. This is also the product rule. You notice there's 2 functions of x. So we have derivative of the first times the second plus the derivative of tangent, which is secant squared times the first. And usually when you have trig and algebra stuff, it looks better to write this in front of the trig just so you don't get confused and think that these are being multiplied together. So that's that one. Find the derivative of this function. Okay, now when you look at this function, if you notice, there is no x. There's no x on top. There's no x on top. It's 7 over x squared plus 3. Since there's not an x on top, I don't have to do the quotient rule. You can just bring up the entire denominator and make it to the -1 power. You could do the quotient rule, but I think that that is a little bit messier. So we'll do this. You bring the -1 down. So -7, you subtract 1. So that makes it negative. Oops. -1 means it's -2. You keep the inside the same. But then the chain rule says you multiply by the derivative. So then this is -7 times 2x over x squared plus 3 to the second power. So -14x over x squared plus 3 squared. Then it says find this whenever it's 2. So we're going to plug in 2. Okay. So that would be -28 over 2 squared is 4 plus 3. 7 squared is 49. Give the slope of the graph, the function at the point 21. Okay, so these are actually the same answer because the slope is the derivative. That's what it wants you to understand. Then it says write an equation. Writing an equation is just y minus the y coordinate equals the slope, which is to be 4 over 7 times x minus the x coordinate, and then you can just add the 1 over. Find the derivative, we've already talked about that. The second derivative, you just take the derivative again. Find the second derivative of secant, that would be secant. The first derivative is secant tangent. And if we find the derivative of the derivative, we're gonna have to use the product rule. So the derivative of secant is secant tangent times tangent plus the derivative of tangent, which is secant squared times secant. So we get secant x tangent squared x plus secant cubed x. This one, the derivative of natural log is u prime over u. So we have derivative of this, which would be 8x over this, 4x squared plus 3. Derivative of natural log, again, when you have natural log of something, it's the derivative of u over u. So the derivative of sine is cosine, put it over sine, and cosine over sine is actually cotangent. And if you have trouble remembering all those trig identities from pre-calculus, I do have a video over that as well that you can look at. Find the derivative of this one, that's just the chain rule. So it's going to be 9x squared plus 2 to the 1/3. You're going to bring the 1/3 down. Keep the inside the same. Subtract 1 is like subtracting 3 over 3 and then multiply by the inside. And then you get 6x over 9x squared plus 2 to the 2/3. And then this one, implicit differentiation, you're going to do the derivative of this, which is 8x times y, plus the derivative of y times the first, plus derivative of 7y squared would be 14y dy dx times x plus the derivative of x times 7y squared equals 0. So here, anytime you take the derivative of a y, make sure you write dy dx. It's kind of like the chain rule. At this point, these things have dy dx and these do not. So you're going to move the things that don't have dy dx to the other side by subtracting or adding them over. Then you pull out dy dx. And then you divide. I'm going to skip that one since it's similar. It's also similar. Find f prime. Okay, so the derivative of this, you can just keep 1 over 27 there. The derivative of x to the 5th is 5x to the 4th. The derivative of 4x cubed is 12x squared. Does f have the inverse function? Yes, as long as it's 1 to 1, it does. And this is because it's an odd function. Consider the real number -13. For what value of x does f of x equal -13? So it's asking, what can I plug in to this function? And the output is -13. So you guess. Usually you guess in this situation. You could actually solve it in your calculator, but a lot of times it's like 1, 2, -2, 3 at the highest. So let's try 2. If I put 2 to the 5th plus 4 times 2 to the 3rd, well, that's for sure not going to be negative. So let's do negative. If I do -2 to the 5th, that is -32. And then minus, let's see, 2 cubed is 8. Wait, 2 to the 5th. -8. That's also 32. So what's 32 and 32? That is -64 over 27. Let me get my calculator out and do some guessing and checking. Okay, so let's try 3. if we do our -3, because it's a -3 to the 5th plus 4 times -3 cubed is -351. If I divide that set 27, I get -13. So it's -3. So -2 didn't work out. So we try -3 and it does work. So when I plug in -3, I get -13. So that's what that's asking here. So -3. Determine the value of that. So the way this works is the inverse, F inverse prime at -13 is 1 over F prime at the value plugged in here, which was -3. So you're going to take the derivative, which we already found right here, and we're going to plug in -3 because that was the original x value. So we're going to plug in -3, not -13, because x's and y's flip-flop on the inverse. So you're going to plug in -3 here. So if I do that, I get 5 times -3 to the 4th plus 12 times -3 squared. I get 513. I get 513, whoops. Over 27, which is 19. And you get the derivative is 1 over 19. It's the reciprocal of that. So that's the answer, 1/19. Again, I found the derivative at the original x value. So we made this the output to the original function. You set this equal, you guess, and whatever the original x is, that's what you plug into the derivative of the original function. And then you flip it and you take the reciprocal. Consider the following function. What's the derivative of arctan? Arctan is u prime, so it's u prime over 1 plus u squared. So derivative of x is 1 over 1 plus squared. For what value of x does f prime of x equal 1/2? So where does this equal 1/2? So I would cross multiply. You would get 2 equals 1 plus x squared, or 1 equals x squared. So that would be x equals plus or minus 1. Find the equations of the tangent line. So point slope, so -1 comma 1 comma -1 if I plug it in here. Arctan -1. So what thing has a tangent of -1? So it's -pi/4. Because arctan only exists on this half. And then pi/4 returns the tangent of 1. And then your slope is 1/2 for both of these. So then it's y minus the y coordinate equals the slope times x minus the x coordinate. Y minus pi/4 equals the slope. Oops, so this would be a plus here, because it's minus and negative, equals 1/2 times x minus 1. And then you could subtract this and simplify it in both of these cases. Okay, dy dt, take the derivative with respect to time. So I'm going to write this as 1 plus x squared to the -1. When I take the derivative using the chain rule, it would be dy, we're taking the derivative with respect to time though. So you write dy dt equals, bring the -1 down, this would become -2. You keep the inside the same, that's the whole idea of the chain rule, but then you multiply by the derivative of the inside, which would be 2x times dx dt. Because when you're taking the derivative with respect to time, you always write d, whatever variable it is, dt, after you take the derivative. Oh. Okay, so we're trying to find dy dt when x is -2. Okay, so this is like -1 over 1 plus x squared. Oh, 2x is there, and then dx dt. So we know that x is, where's x? -2. So it'd be -2 times -2, 1 plus -2 squared, and we know dx dt is 7. So you just need to multiply that all out. So that would be 4 on top times 7 over 4, 5, 25. 28 over 25. Yeah. When x is 0, then you just plug in 0 over here. And then when x is 2, so you just take turns plugging in that value of x to see what the answers are. The radius of a circle is increasing. Anytime you see that phrase, you know you're going to write down d something dt. Increasing at a rate. So dr dt, because it's radius, this is for radius, 3 centimeters per minute. Find the rate of change of the area. So we're looking for dA dt when r is 29. The area of a circle is pi r squared. We take the derivative with respect to time. So we bring down the 2 pi r, we write dr dt. And we plug in our stuff. 2 pi radius is 29. dr dt is 3. So 29 times 2. So 174 pi is this answer right here. Okay, and then we have the radius of a sphere is increasing at a rate of 3 inches per minute. So radius is increasing at a rate of 3 inches per minute. Find the rate of change of the volume when the r is 8. Volume of a sphere is 4/3 pi r cubed. We're going to take the derivative of this, and that would be dv dt equals, equals 4 pi r squared dr dt. And then we're going to, hold on a little bit. And then we're going to plug in r is 8. And dr dt is 3. So you just multiply that together and you put that right here. And this is a very similar idea. You just use 35 instead of 8. So the sphere and the circle are fairly straightforward. Yes, so that's also very straightforward. Explain why the radius of the change of the radius of the sphere is not constant, even though dv dt is constant. dr dt as a function runs parallel to the volume function, which is not linear. The rate of change of the radius is a linear relationship whose slope is dv dt. Okay, so let's look at volume is 4/3 pi r cubed. The derivative of it is 4 pi r squared dr dt. It's not linear. It's not cubed. This dr dt depends on r squared, not simply r. So what's the last one? Okay. All edges of a cube are expanding at a rate of 3 centimeters per second. So ds dt equals 3. How fast is the volume changing when the side is 1? So the volume of a sphere is, a cube is just s cubed. So taking the derivative of this, you get dv dt as 3s squared ds dt. dv is question mark, s side length is 1, ds dt is 3. So 3 times 1 times 3 is 9. How fast is the volume changing when it's 11? So then you just plug in 11 here and get that answer. All edges of a cube are expanding at a rate of 5 centimeters per second. Hold on just a second. Okay, let's finish up. We're almost done. Okay, this question has several parts. The sand on a gravel plant is falling on a conveyor belt. Oh man, my tools went away. Hold on. Okay, so we got a conical pile at a rate of 7 cubic feet per minute. So dv dt is 7 cubic feet per minute. The diameter of the base of the cone is 3 times the altitude. So diameter equals 3h. Now, if you remember for a circle, you have the radius and you have the diameter. And the radius two of them is equal to the diameter. So you would have 2r equals 3h, or r equals 3h height. At what rate is the height of the pile changing? So we're looking for dh dt when h is 17. So for a cone, the volume is 1/3 pi r squared h. And the way the cone problem works is you need to make sure you pause and check for your variables, and you're going to need to figure out r, because we have a dv dt and we have a dh dt, but we don't have a dr dt. So you need to substitute in the relationship that r has with h. You cannot put a constant, but you get to put its proportion. Okay, so this is 1/3 pi. Instead of r, we're going to write 3/2 h squared times h. When we multiply that out, we get 1/3 pi. 3 squared is 9, h squared is h squared, times h would be h cubed. 2 squared is 4. Now we have not even taken the derivative though. So you need to take the derivative of this. And these 3's are going to cancel, and you're going to get pi 9/4 h squared dh dt. At this point, you can just plug in your things. So we know h is 17, so you're going to plug in 17 there, and dh dt, dv dt is 7. So we're going to get 7 equals pi/4 9 times 17 squared dh dt. Okay. 17 squared is 289 times 9 is 2601 over 4 pi. So you're going to multiply this by 4 and divide by 2601 pi. So 28. So yeah, that doesn't simplify very nicely. So 28/2601 pi is equal to dh dt. So that's how you do that problem. Last one, hooray! Okay, a silver dollar is dropped from the top of a building that is 1320 feet tall. Use the position function, determine the position and velocity function of the coin. So its initial speed its initial velocity is 0 because it just dropped. So it goes away, and this initial position S naught is 1320. So that goes here. So -16 t squared plus 1320. The velocity is just the derivative of this. So it's -32 t. Determine the average velocity. Average velocity means you take position, it's the change in position over the change in time. So we plug in 2 into this function and plug in 1 into that function and subtract. So -16 times 2 squared plus 1320 is 1256, minus when I plug in 1, I get 1304, divided by 1, so 1256 minus 1304, -48. Find the instantaneous velocities. The instantaneous velocity is using the velocity function. So this would be -32, and this would be -32 times 2, so that would be -64. That's just using this function here and plugging in for time. Find the time required for the coin to reach the ground. Okay, so the position at the ground is 0. So it's just basically asking, when does the position equal 0? So when does 16 t squared plus 1320 equal 0? So we're going to subtract 1320, divide by -16. So 1320 divided by 16 is 82.5. Take the square root of that. So 9.083. Find the velocity of the coin at impact. So what is the velocity at this time? Is what it's asking. So plug this again into the velocity function here, or just multiply that times -32. So -290.654. Okay, guys, please reach out with questions. Remember, your final will replace your one lowest test. That it's really important that you don't give up. You have 4 exams. Each one is a good chunk of your grade. So please try your best, and good luck.